The following screencast is part 5 in our series of fine cycle peak detector demonstrations. And in this episode we're going to look at two different ways in which you can use the fine cycle peak detector to display the data in different views. The first demonstration will be showing you how to average a waveform, and then the second one will demonstrate how to use the 3D surface view. Now, this particular file that I've got in front of me is an ECG file. If we zoom in, get a closer view. So it's just a typical ECG waveform. When we look a little more closely, you can actually see that our subject changed positions during the recording. So at some point, I'm guessing they were probably lying down, sitting up. But hopefully if we average the waveforms during the two periods, we should be able to highlight a change in the overall averages for sitting and standing, or laying and sitting, depends on what the subject was doing. So to start off with, I'm going to highlight a period of data, like so. Go to the fine cycle peak detector, and the software is going to set a threshold based on the area that I've selected. I've got my selection cursor set so that we're going to actually find the peak of the R wave, and we're going to set the left cursor, or the left edge of the measurement region, to 450 milliseconds prior to the R wave, and then the right edge, the second cursor, will be placed at 450 milliseconds after the R wave. So we've got a total window width of 900 milliseconds. If we go to the output option, turn this off for the moment, I'm going to go into averaging, and I'm going to construct an average from channel 1. I'm going to just get an average of the cycles in the selected area. And I'm going to select Find Selected Area. So here we have it. This is the average waveform. Adjust the window a little bit. This is the average ECG complex for the first area of data. I'm going to do exactly the same again, only this time I'm going to select this portion of data over here. Actually, I'm going to just put first on there so that we know which one's which. And I'm going to do exactly the same again. Output, averaging the selected area, find in selected area, and there we have it. There's the average for this region. What I'm going to do here is come in, select all, I'm going to copy, I'm going to insert waveform. So this is the first waveform from the first period of data. If I open this out a little bit, I'm going to turn some of this stuff off so we've got a little better view. Oops. Okay, turn my grid off for both channels. And I'm going to scale these so that we're using exactly the same scale for the two waveforms. So now vertically they're scaled the same, and horizontally they're on the same axis with the same timing. And if I go to overlap mode, we can now see the difference between the two averaged waveforms. split that out. So the red is from the first period of the recording and the blue is from the second period. You can see how the T wave is changed between the two periods. The R wave hasn't changed much at all. A little bit of a change in the P wave. But anyway, that's a quick demonstration of how you can use the software to take an average of different periods of data. So the second thing I'm going to do is highlight an area of data like so. Go back into the peak detector. I'm going to leave everything set up the way it was before. This time I'm going to turn the average off. And I'm going to generate a 3D surface area within the selected region. So this will take a little while because there's a lot of data there. But basically what will happen is the software is going to identify each of the cycles and plot them one behind the other. So we get this 3D, if I can adjust this down a little bit, 3D representation. Now if I rotate this around, you can see this is the point where the person changed their position. And as we saw in the average, we saw that there was also a change in the T wave, and we can see how that change has impacted the waveform, and it shows up quite nicely on this 3D plot. Okay. So that gives you a quick example of how you can use peaks in the data to get two different views of your waveform. Anyway, that concludes this demonstration of the fine cycle peak detector.